Now, when you make an assumption, you make an, I can't make that joke on a school channel, can I? Well, I messed up on one of the earlier videos this summer, and today we're going to fix that mistake. In the second of the summer slide series, I went on a search throughout the universe for the mysterious rebel in the hunting dogs, based on this photographic slide. But the search was doomed from the start, as I made two mistakes before I even got started, which made me thinking that the wrong galaxy was the rebel in the hunting dogs. Who's got an interest in photography, a master's degree in physics with astrophysics, didn't recognise that this image wasn't a photo, and two thumbs? This guy! As the slide was in a collection alongside so many photographs, I didn't stop to think if it was a drawing or not. To be fair, I should have realised from the Knack J. Herschel, meaning according to J. Herschel, which indicated that he was the astronomer or the artist. My logic on this was based on looking up John Herschel's career. He catalogued around 3,500 nebulae or star systems during his career, so looking through a full list of these and looking for images associated with each and every one of them was not something that I was prepared to do the legwork on. This obviously wasn't my smartest choice, and meant that I spent loads of time trawling through photographic records looking for something that looked exactly like the image instead of an artist's impression. The reason that the image looks so little like the actual galaxy is due to the equipment used. John Herschel made the observations of the galaxy using a reflector telescope with an aperture, diameter, of 18 inches, so just 1.5 feet. The reason that this matters is due to something called Rayleigh's criterion. This tells us about the angular resolution of a telescope. In other words, the smallest angle in the sky that your telescope or any viewing device can see two objects as being separate. For anyone studying AQA A-level physics and taking the astrophysics option module, you need to know this approximation of the equation with the angular resolution depending on the wavelength that you're observing in and the diameter of your telescope. This version is in the formula booklet, unlike the variation of this that comes up for electron diffraction of the nucleus in Unit 8, nuclear physics, so it's worth learning both versions. When viewed with the naked eye, galaxies generally look like dots at best, but the larger the aperture on a telescope, the greater the detail you will be able to see. These three illustrations, with progressively larger instruments, allow us to quite clearly see the benefits of a telescope with as large an aperture as possible, and why I spent most of my time looking for ring galaxies instead of spiral ones. My second mistake was another one that led me in the wrong direction. I misread the first letter on the slide's description as an R when it should have been an N. Therefore, I wasn't looking for a rebel in the hunting dogs, but a Nebel, which is German for nebula. Or fog, but nebula obviously makes more sense. As we discussed in last week's video, until the 1920s, the wider astronomical community didn't actually accept the existence of other galaxies, and so referred to what they actually saw in the sky as nebulae instead. Had I read that properly, it would have led to a lot less inaccurate searching for a rebel, which resulted in several dead ends. Both of these errors were pointed out in the comments within 24 hours of the original video going live, with one even finding the actual galaxy, M51, and finding the book that it was from, original caption and all. Which book, you might ask? This one, of course. For those of us who are wondering, I didn't own this previously. I bought it once I'd found out about its existence. The book itself is Die Wunder der Sternenwelt, ein Ausflug in den Himmelsraum, published in 1877, and it contains a wealth of illustrations covering a range of astronomical phenomena, giving a great flavour of astronomy back in the 1800s. But I didn't just find the Nebel in the hunting dogs image in this book. Flicking through, I also found this one, in the top left, which is also in our collection. This slide shows a series of 6 images, all demonstrating other ringformige Nebel, which translates as ringform nebulae. These were more galaxies as viewed through telescopes of that era. Based on the drawing from the other slide, they may not be ring galaxies, but just spiral galaxies through relatively small telescopes. As such, I'm not going to try and identify all, or in fact any of these. As we've already established, I don't have the best track record on this. Several things, really. First was to be careful with the assumptions you make in life. They may have good intentions, but can lead you in completely the wrong direction. Second, own your mistakes. You learn so much more from getting things wrong in life than you do from getting them right. So don't be afraid to try something and fail, because that gives you the greatest opportunity to improve. Third was that I decided to look into the origin of more of the slides to see if I could figure out where some of the others had come from. The majority of the slides in the collection have 3 letters on them, RAS. This stands for the Royal Astronomical Society, and these slides seem to be part of a numbered collection that was possibly commercially available for enthusiasts, educators, and whoever else was interested in seeing high quality images of space for the time. I did find some more slides from the archives from the Royal Astronomical Society Canada, though had no joy in finding the complete collection. What I did find, though, that we can see here, was restored footage of the first ever solar eclipse to be captured on film from North Carolina in 1900. Looking through the other slides, a few were produced by a company called Flatters and Garnet Limited. Based out of Manchester, they operated from around the start of the 20th century until the late 1960s. During this time, they produced microscopes, slide projectors, and a range of slides across a wide array of subjects to aid educators. Based on the address on the slide for Saturn, which we used in the first summer slide video, this was produced sometime between 1913, when they moved to Oxford Road, and 1932, where they moved several departments to Fallowfield for a more spacious and quieter working environment. A few of the other slides in the collection are from a company called J.T. Chapman Limited. This was also based in Manchester and ran from the 1870s until the 1960s. Because the slides do not have a specific site address on them, it's hard to identify which era of the company they are from, but I would assume that they were purchased at a similar era to the Flatters and Garnet collection. The quality on these slides is really high, with clear imagery and detailed labelling that makes them a lot more accessible than some of the others in the overall collection. What this does suggest is that either there was a wide reach for Flatters and Garnet Limited alongside J.T. Chapman Limited, or that Adams had a strong link to Manchester around 100 years ago. This is a mystery that I'm not going to be able to solve, alongside how we have 2 slides in the collection with a handwritten note saying that they are from the Lick Observatory, which is based in California, USA, and don't seem to have come from any of the other aforementioned slide collections. For now, though, I'm going to do my best to translate my way through parts of this book to understand more about the hand-drawn slides and start scripting the last of the summer slide series, which is going to look at how technology has moved on in astronomy in the last 100 years since this collection was produced. While I'm busy doing that, please do give this video a like if you've enjoyed it. Let us know if there's anything you would like us to research further in the comments, and subscribe to our channel for more weekly content on astronomy. As ever, until next time, please continue to watch this space. Thank you.